In numerous fields of study, the component of instability within a system is generally characterized by some of the outputs or internal states growing without bounds. Not all systems that are not stable are unstable. Systems can also be marginally stable or exhibit limit cycle behavior. In structural engineering, a structure can become unstable when excessive load is applied. Beyond a certain threshold, structural deflections magnify stresses, which in turn increases deflections. This can take the form of buckling or crippling. The general field of study is called structural stability. Atmospheric instability is a major component of all weather systems on Earth. Instability in control systems. In the theory of dynamical systems, a state variable in a system is said to be unstable if it evolves without bounds. A system itself is said to be unstable if at least one of its state variables is unstable. In continuous time control theory, a system is unstable if any of the roots of its characteristic equation has real part greater than 0. This is equivalent to any of the eigenvalues of the state matrix having either real part greater than 0, or, for the eigenvalues on the imaginary axis, the algebraic multiplicity being larger than the geometric multiplicity. The equivalent condition in discrete time is that at least one of the eigenvalues is greater than 1 in absolute value, or that 2 or more eigenvalues are equal and of unit absolute value. Instability in solid mechanics. Buckling. Elastic instability. Drucker stability of a nonlinear constitutive model. Biot instability. Baroclinic instability. Fluid instabilities. Fluid instabilities occur in liquids, gases and plasmas, and are often characterized by the shape that form. They are studied in fluid dynamics and magnetohydrodynamics. Fluid instabilities include ballooning mode instability, found in the magnetosphere, atmospheric instability, hydrodynamic instability or dynamic instability, inertial instability, baroclinic instability, symmetric instability, conditional symmetric or convective symmetric instability, barotropic instability, Helmholtz or shearing instability, rotational instability, hydrostatic instability or static instability, vertical instability, thermodynamic instability, conditional or static instability, buoyant instability, latent instability, non-local static instability, conditional symmetric instability, convective, potential, or thermal instability. Convective instability of the first and second kind, absolute or mechanical instability. Bernard instability, drift mirror instability, Kelvin-Helmholtz instability, Rayleigh-Taylor instability, Plateau-Rayleigh instability, Richtmeier-Meshkov instability, shock wave instability, plasma instabilities. Plasma instabilities can be divided into two general groups: hydrodynamic instabilities, kinetic instabilities. Plasma instabilities are also categorized into different modes. See this paragraph in Plasma stability. Instabilities of stellar systems. Galaxies and star clusters can be unstable if small perturbations in the gravitational potential cause changes in the density that reinforce the original perturbation. Such instabilities usually require that the motions of stars be highly correlated, so that the perturbation is not smeared out by random motions. After the instability has run its course, the system is typically hotter or rounder than before. Instabilities in stellar systems include bar instability of rapidly rotating disks, Jeans instability, firehose instability, graver thermal instability, radial orbit instability, various instabilities in cold rotating disks, joint instabilities. The most common residual disability after any sprain in the body is instability. Mechanical instability includes insufficient stabilizing structures and mobility that exceed the physiological limits. Functional instability involves recurrent sprains or a feeling of giving way of the injured joint. Injuries cause proprioceptive deficits and impaired postural control in the joint. Individuals with muscular weakness, occult instability, and decreased postural control are more susceptible to injury than those with better postural control. Instability leads to an increase in postural sway, the measurement of the time and distance a subject spends away from an ideal center of pressure. The measurement of a subject's postural sway can be calculated through testing center of pressure, which is defined as the vertical projection of center of mass on the ground. Investigators have theorized that if injuries to joints cause deafferentation, the interruption of sensory nerve fibers, and functional instability, then a subject's postural sway should be altered. Joint stability can be enhanced by the use of an external support system, like a brace, to alter body mechanics. The mechanical support provided by a brace provides cutaneous afferent feedback in maintaining postural control and increasing stability.